picture of Naples in the sunshine. It brought back very pleasant memories when we were all there on the seafront. And one of the things I particularly remember about that conference was I was walking past a rather large window and I saw Dan Christian Bogos on the other side of the window, who had somehow locked himself out of the hotel. I don't know how he did that, but we let him back in, and he was able to continue with his participation.
That's the kind of things that can only happen in our kind of conferences. Yeah.
It very much is. It was quite strange at the time, but very memorable. Anyway, Lorenzo, we're very grateful that you did that talk on NDI earlier. What kind of things are going to be in this workshop that we're about to start?
Yeah, it's going to be some sort of a part 2 of the workshop that we did on Janus this summer as well. So in this summer, I gave a more generic introduction on what Janus is, the different plugins, gave some demos of the different things that you can do, combining different applications and so on. And this time, I thought I'd more on a more specific functionality of Janus, that is basically its ability to act as an enabler of sorts. So then just stay within the WebRTC world, how you can have Janus make the integration and interaction other applications that do not necessarily know anything about WebRTC and communicate with those somehow for different purposes, including just scalability and these sort of things. So I'll show some demos that show basically how you can play with plain RTP and how Janus makes that possible.
Okay, that's great. I wanted to ask you a question just about the history and background of Janus. I saw on your slide earlier on that it had Meet Echo going since 2009. Did you start work on Janus immediately within Meet Echo, or did that come a little bit later?
No, that actually came a bit later, but not much later, I think. So because at the time when we founded Meet Echo, it was basically to try and commercialize all the research efforts that we had been doing at the university, because we all have an academic background. Simon, who you met, is one of the co-founders, was our professor at the time. So we all got our master thesis and PhD with him. And at the time, we were mostly focused on just web conferencing. Then we started working on media servers from a standards perspective in the ITF, and then we slowly started moving towards web integrations and stuff like this. And so it was, I think WebRTC started to come out 2 or 3 years after that. And as soon as that happened, we first started tinkering with other open source applications to do what we needed. And then we found out that we actually needed something like Janus to do what we needed to do. So in fact, Meet Echo is about to turn 12 years in a few months, and Janus itself is 7 years old. So it was about, let's say, 4 or 5 years before Janus was actually released, even though we had started working on it a bit sooner than that.
Right, and I know across that same period of history, you've managed to acquire a number of guitars as well in an unrelated incident.
Yeah, there are some on the side here. I may show some of them on the during the course of this workshop, but I will not say when, so that everybody stays.
Okay, we'll be looking out for that. But interested to hear about Janus. I would point out just before we start that Lorenzo is one of a set of 3 Lorenzos in VoIP and RTC. There are probably more. And all Lorenzos are important, but the 3 that we tend to come across are the Lorenzo Miniero in the big picture there, but we've also got Lorenzo Mangani from the Homer project. In fact, he's just unmuted his video and he's going like this at the moment. Good to see you down there, Lorenzo. Great to have you along. We're looking forward to your workshop as well. And then, of course, there is Lorenzo, a military from the Lowway, from the people that do Q-metrics, and he's participated in ClueCon before as well. So we like to keep the 3 Lorenzos very close to ClueCon. But now, let me not go on any longer. We're excited to hear what you've got to say, Lorenzo Miniero. So we'll hand over to you and your presentation. Thank you.
So I did prepare some slides, even though I want to focus more on some demos and show you how you can actually tinker with some things proactively. So I'll show some JavaScript code that shows you how you can do some things. I'll show some scripts that show how you can play with things. But I still wanted to have some slides to have you basically have something that can anchor the concepts that I'll introduce a bit better. So Without further ado, let me find where the window is. Also, I won't delve too much on this slide also because I already went through this in my NDI slide before, but just to go quickly again, I'm Lorenzo Miniero. I got my PhD at the University of Naples, and I'm one of the co-founders of Miteco and the main author of the Janus WebRTC Gateway. We are a small company in the south of Italy, which is beautifully depicted here, as David said. So, and in fact, as David mentioned, the conference that we had, which was actually held here, so right on the sea in front of this gorgeous castle, which is Castel del Lovo. Hopefully sooner we'll be able to have this conference again, and we'll be able to meet in person in front of a delicious pizza without pineapple, of course. That's very important. And as I was mentioning in the intro, this is supposed to be kind of a part 2 rather than a complete workshop on Janus. So I'll assume that you are already a bit familiar with Janus, even though you don't really need to know much about Janus in the first place. So I don't really expect you to know many of the concepts in details, if not that it is a WebRTC server that allows you to do a few things. If you want to learn more about the specifics of Janus and how Janus works from the ground, that link over there is a good starting point because it's the workshop that I did in the summer and at ClueCon again, and gives a good overview, I think, about the different things that Janus can do, how it works internally, the different plugins that it provides out of the box, and how you can basically combine them. But just to give you some, let's say, a very quick recap of what Janus is, it's basically a WebRTC server that we conceive to be general purpose in nature. So it's, of course, open source, and you can find the whole project, and including the demos on that repository on GitHub over there. We also have some demos online that you can play with before actually installing Janus yourself, including an extensive documentation. And we also have what I think is a good and active community. So if you're interested in Janus, feel free to join the Google group that you see there, and you'll find many other people interested in working with Janus and trying to help each other with issues that they may encounter on a daily basis. And again, just to give you a quick recap, so not really going to go too much in detail in this, but Janus, as I was saying, was conceived to be general purpose, and this is made possible by the fact that we conceived it with a modular architecture. So you have the Janus core itself that is responsible for the whole WebRTC stack. So it takes care of all the negotiation via SDP and its JavaScript counterparts. So all the ICE stack, the DTLS stack, all the data channels implementations, and so on. So everything that belongs to the WebRTC layer is actually implemented within Janus itself. And this is done on purpose so that we can extend Janus in terms of functionality without having to re-implement the whole stack over and over again when we just want to add new functionality, let's say. In fact, apart from this WebRTC stack hard-coded in the core, everything else is pretty much conceived to be modular. So we have a Janus API that is based on JSON that you can use to communicate with Janus, but how you transport these Janus API messages back and forth is really up to you, because you can use HTTP and WebSockets if you're talking to Janus from a browser, let's say. But we also have other lower level protocols like RabbitMQ, MQTT, Unix sockets, and NanoMessage that you can also make use of in case you are actually talking to Janus from the server side instead. For instance, you are implementing some sort of a controller and using Janus as a media server instead, exposing your own API to end users. The application logic, so how you handle media, is also implemented in plugins. And the idea was basically that you have different plugins that implement different functionality, like, for instance, video SFU that is the video room, an audio MCU, SIP stuff, broadcasting, and so on. These are all different plugins that are actually loaded by the core, and none of these plugins are actually strictly speaking, aware of WebRTC itself. So they are aware of negotiation, they are aware of RTP, they are aware of codecs and stuff like this, but they do not need to know anything specific about WebRTC itself. So all of these aspects, as I was anticipating, are done by Janus itself. So these plugins just need to be prepared to receive RTP packets because a user connected to the plugin, and may be needed to be prepared to also send media in case they are actually originating media somehow, relaying and stuff like this. And this is all made possible by the fact that since the Janus is modular and these plugins have different behaviors, we also implemented the Janus API to be extensible as well, which means that you have the Janus API that can act as a transport for the communication with different plugins, mostly because each of these plugins has its own functionality and its own requirements. So I often make the example, for instance, that the SIP plugin is very different from the SFU video conferencing plugin. And so they do need different ways of actually interacting with users because they have different requirements. And so the only way to make this possible is to ensure that the Janus API itself can be customized and specialized whenever you talk to a plugin rather than another. And most importantly, this heterogeneity in how plugins are handled needs to be applied also to how you handle media itself. So at the end of the day, with WebRTC, you create one or more peer connections between a browser or a mobile endpoint or a WebRTC endpoint in general and the WebRTC server itself, in this case, Janus. So the whole idea is that a browser creates a signaling channel with Janus somehow, exchanges Janus API messages that may involve one or more plugins. And these signaling may result in the creation of one or more peer connections. And each of these WebRTC peer connections may be handled by one or more plugins, depending on how the application logic is conceived. And more specifically, in this case, for instance, we have this browser that created two different peer connections, two different WebRTC peer connections that are terminated by Janus. And in this case, this reddish peer connection is actually hooked up to this red plugin over here, which means that this plugin is made aware of the RTP packets that are arriving here and can send RTP packets back that will be sent here. At the same time, this green peer connection is connected to this other plugin instead, which means that from a user experience point of view, we just see WebRTC connections. We really don't need to know that they are actually originated by different plugins and that our media is being handled by different plugins. This is just done by Janus transparently. The important part of this presentation as a whole is that I will focus on this aspect over here. So anytime that one of the plugins in Janus, may it be one of the existing plugins or a new plugin that you write from scratch, anytime that such a plugin needs to interact with another component for whatever reason, and I'll show some examples later, which may be, for instance, a SIP plugin that needs to interact with SIP endpoints via plain RTP, or it may be broadcasting or analysis of a stream or things like this. We'll see some examples later, but this is really the part that I want to focus on. And so these are the examples that I want to show, and how in this case Janus can indeed act as an enabler for technologies that are not really WebRTC compliant. So if you assume that here you can have anything at all, it means that you can have a component that may be consumed or interacted with via a browser, via WebRTC, even though this component knows nothing about WebRTC in the first place. And of course, the first example that comes to mind, as I was saying, is the SIP plugin itself. So the SIP plugin is very simply a SIP stack sitting within Janus itself. So the SIP plugin actually implements a SIP stack using the Sophia SIP stack, the same one that FreeSwitch uses itself. And basically, its behavior is quite simple. So you have browsers, for instance, a WebRTC user creating a signaling session with Janus using the Janus API. And so this can be done via HTTP or WebSockets, using the a JSON formatted protocol for the Janus API, and creates peer connections over here. On the SIP plugin side, you create SIP messages instead, which means that the browser here never sees SIP messages in the first place. So everything that is related to SIP is actually originated by the SIP plugin, which means that this user may say, call this SIP URI, and this is translated in creating a SIP stack on behalf of the user and actually doing all the exchanges, all the SIP dialogues to make that happen. And if this translates to an RTP session being created between the SIP plugin and a SIP infrastructure somewhere, then this RTP session over here is bridged to this WebRTC session over here. And so in this case, you can see that if we assume that this SIP infrastructure is not WebRTC aware at all, but is, let's say, an older infrastructure that just talks SIP over UDP and just plain RTP, for instance, and you still want that infrastructure to be WebRTC compliant, putting Janus and the SIP plugin in front of that is actually a good way to do that, because it basically abstracts everything for you and you don't need to change anything here, because this infrastructure will keep on seeing regular SIP, will keep on seeing regular RTP, and it will be Janus itself that will take care of making these WebRTC compliant for users here. And a slightly different approach is provided by a similar plugin that we call the no-SIP, where in this case, this no-SIP plugin does a similar thing to what the SIP has with respect to media, but without the SIP stack bundled in itself, which means that it leaves all the SIP messaging up to you, and you may do this, for instance, via Kamailio or OpenSIPs or whatever you are more familiar with, and then only involve the Janus for the media part. In this case, Janus only acts as a media gateway of sorts. And this basically works by using the signaling channel to exchange, to basically swap SDPs back and forth. So for instance, the WebRTC participant will generate a WebRTC SDP, which an older infrastructure would not be able to recognize. And so what you do is you provide this WebRTC SDP to the no-SIP plugin. The no-SIP plugin will give you a bare-bone SDP where it binds to a couple of ports to do a more traditional RTP session, so that you can use this more boring SDP in your own SIP message that you then send to this other SIP infrastructure. The moment you get back a response with a boring old SDP in there, you pass it back to Janus. Janus gives you back a WebRTC SDP. And the end result at the end of the day is that you have a WebRTC session over here and a plain RTP session over here, which are actually bridged one to the other thanks to Janus itself. And again, this is not rocket science. Of course, there are several different ways of doing this, also using other components, but it's just to give you a very quick overview of what you can already do with plain RTP from the very beginning. So assuming that a regular session via SIP is done instead. But these are not the demos that I wanted to show. So I wanted to show something a bit more different and a bit more out of context, if you will. So something that doesn't really need to involve a session setup of any sort, at least not necessarily. And one of the plugins that we use the most for that is actually the so-called streaming plugin. And this streaming plugin is very simply a plugin that allows you to create what we call mount points. So you create a node of some sort that can receive plain RTP from any component, which can be GStreamer, FFmpeg, an RTSP camera, as I show you in a minute, VLC, or even, as we'll see later, other Janus instances. Let's say more in general, this plugin can receive a plain RTP stream from a source of some sort and can turn this into a WebRTC broadcast instead, which means that if I create a video stream via FFmpeg, for instance, I encode it the way that WebRTC endpoints are able to decode, for instance, using Opus and VP8, I only send this once, this becomes a broadcast that more people can subscribe to. And this actually opens the door to a lot of interesting scenarios. And so let's start showing some demos on exactly this then. And first of all, let's have a look at the streaming plugin demo itself, that, as you'll see, sorry, I should have started Janus over here, I forgot. Let's start Janus and let's connect to it. In this case, there are a few streaming mount points already created, but they are, we want to create something from scratch again. So let's try to create a new streaming mount point that will feed with a script instead. And more in particular, I want to show you this simple script that I'll be using. In particular, first of all, can you read this, or is it too small? So just let me know if you want me to make that shell larger, or if I can just proceed like that. So it's not really important that you manage to read exactly what is in the script, but it's just to give you an overview of what is in there. And more in particular, I want to use this script that I call ironmaiden.sh, which basically takes a WebM and an Opus pre-recorded video and audio files, and then packetizes them within GStreamer and sends them via UDP to a couple of ports, in this case 9002 or 9004. So if we want this stream that we are sending via GStreamer to be consumed via WebRTC as a broadcast, what we can do is actually use the streaming plugin for the purpose. And we can create, in this case, either a mount point statically or dynamically, and we'll create one dynamically just to show the things that we can do. Actually, before showing that, I want to show a simpler example. So I was saying here that we can use GStreamer and FFmpeg and other tools and so on, but a very first example we can start from is actually starting from an existing camera. In this case, I have an RTSP camera sitting right next to me over there, which is actually up and running. So I can show, for instance, let's see where it is. I can, for instance, I can open it via mPlayer, which is an application on Linux, and I can open this RTSP link. And here you should see, this is basically my very messy home. So don't look, don't pay too much attention at the disorder over there. You can see a couple of furry friends over here sleeping it off. And in this case, you can see I'm just receiving this RTSP stream using a custom application. What if I wanted to consume this RTSP stream via WebRTC instead? And this is something that I can do quite easily with the streaming plugin itself. And let me show you exactly how. In this case, I have I'll use the JavaScript console that is open on this streaming demo to send a message to the plugin, mostly because since in this demo, I already created a session with the streaming plugin, so I can send messages back and forth so that I can create stuff. In this case, I can basically send a message to the streaming plugin where I ask to create an RTSP session. I provide the address of the RTSP server, which in this case is the camera over here. And then I provide the credentials to actually access the RTSP camera because it is password protected. So what happens is I send this message. I should receive a created back in a second as soon as the camera answers. So here it is. And in fact, if I look at Janus, I'll see that on the logs, I can already see that a new video stream is being received by Janus. And what happened in this case? Basically, exactly as what typically happens in the C plugin, I basically asked the streaming plugin to create an RTSP session with the camera behind the curtain. So it basically established the RTSP session, which eventually ended up with the camera sending an RTP stream towards the streaming plugin, which means that now it is available as a WebRTC stream via Janus itself. So just let's see if we can actually see it. In fact, here it is. Let's watch it. And in fact, here it is. It's exactly the same camera that we were seeing before. So let's also see. Let's also send some commands to show that it's actually the camera that I'm talking about. I have basically this camera can be controlled via HTTP. So I can, for instance, do a move right to show that it's going to me. Here I am. Or maybe I can move it back to where it was before. And as you can see, it's making an RTSP stream available via WebRTC was very easy. And this is a feature that a lot of people are actually using every day to make their own surveillance camera accessible via WebRTC without too much of an effort, for instance. But as I was saying, if we want to do this without any kind of signaling instead, one of the things we can do is indeed use more generic tools like GStreamer, FFmpeg, and so on. So let's go back to the example that I wanted to show you before. let's say that I want to send a stream completely out of context. So I just want to generate a stream via GStreamer. In this case, I'm picking recorded audio and video files, and I want to send them via RTP to Janus at these addresses. What I need to do is make sure that Janus is prepared to receive media on these two ports. And he's aware that this needs to be an Opus stream and this needs to be a VP8 stream. So what I do is basically just send a message pretty much as we've seen it before, with the difference that I'm not going to create an RTSP stream right now. I'm going to create a plain RTP stream. And in this case, what I'm going to do is I'm going to create a plain RTP stream. This is the description that it will have, which was I'm basically sending the video, one of the videos by Iron Maiden, one of my favorite bands. I'm going to say that I want both audio and video to be created, and audio needs to be bound to this port over here, 9002. Video needs to be bound to port 9004, and this is going to be an Opus stream for audio and VP8 stream for video. And the streaming plugin really doesn't care about what codecs are being used because it doesn't transcode anything. It's just relays packets back and forth. But this is needed because we need to create an SDP out of this on the WebRTC side. So let's create this mount point as well. This has been created much more quickly, as you see. If I update it now, I see it over here. If I open it right now, nothing will happen. So the peer connection is created, but nothing is displayed because I'm not sending anything yet. So let's use GStreamer to actually send this stream over here. And now GStreamer is actually sending these streams that I created, and I can verify over here that on the Janus side, I can see that I now see an audio and video streaming coming on this mount point that I just created. So let's just watch it. And here it is. So let me mute it because even though I love this song, it's going to be a bit complex to talk while I'm listening to it. And so right now, as you can see, this is a video stream that actually a tool that is not conceived to talk to WebRTC as it is right now is generating. So in this case, I'm just generating a plain RTP stream, sending it to Janus, and Janus is turning it into a broadcast for me instead. And when I mean broadcast, I mean that now it's just me watching it, but this could actually be attended by a lot more people at the same time, because the moment I create a mount point, it means that many people can subscribe to the same stream at the same time, which means that it's very easy to just generate a single stream using any kind of tool that you're familiar with, and then make it accessible to a lot of people at the same time as a broadcast instead. So it's quite effective, if you will. And but again, this is just a very simple example of how we can use the streaming plugin for that, which is useful, of course, but is useful mostly when we want to do, let's say, non-WebRTC world to WebRTC world. If we want to do the other way around, so possibly, for instance, have a WebRTC user send media and then use this media somehow, this is an entirely different matter that the streaming plugin cannot really help with, at least not by itself. So what needs to happen is something different. And typically we need to start looking at some of the more proactive plugins that are out there. And one of those is the Audio Bridge plugin, which is basically one of the so-called WebRTC only plugins. And the Audio Bridge plugin is basically an audio MCU, so an audio mixer, if you will. And it allows you to have one or more people join an audio room and chatting with each other just via audio, where the audio is completely mixed. The main point here is that all the participants in this conversation need to be just WebRTC compliant. And but sometimes we want this audio mix to be available outside of the audio bridge itself or outside of the context of these WebRTC participants. And one way to do that is using what we typically call RTP forwarders. And I'll get to those in a minute. At the same time, when the video room plugin implements a so-called SFU, so where you have, for instance, a video conference with 4, 5, 10 people talking to each other, where video is not mixed together, but just relayed. So you send media once and the server takes care of forwarding it to the 9 other people in the room. And it does the same for media coming from the other participants instead. And so in this case, you can see that the media basically just goes from one participant and reaches the others. But again, we may want this media to be available outside of this WebRTC conversation as well, because it's great that we can have this video conversation among browsers, but sometimes we need to have access to these WebRTC streams to do something more complex than that we may want to do. And as I was anticipating, this is what RTP forwarders are for, which is a concept that we introduced in Janus a few years ago. And both the Audio Bridge and the Video Room plugin allow you to do exactly that, mostly because, as I was describing previously at the beginning of when I was basically doing a quick recap of Janus, plugins do not need to care about WebRTC itself. The Janus core takes care of that. The moment a peer connection exists and is connected to a plugin, it means that this plugin has access to the unencrypted plain RTP packets that these users send, so that they can do whatever they want with it. So the SIP plugin may want to send it to a SIP soft phone somewhere. The Video Room plugin may want to relay it to other participants in the room, and so on and so forth. So the Audio Bridge may want to mix them, and so on. In this case, these RTP forwarders, as the name suggests, do nothing more than basically taking these RTP stream packets that you are receiving and forward them exactly as they are, as plain RTP or possibly via SDS RTP, to an address that you specify. So, for instance, you have a component listening somewhere on a specific port that is aware of RTP, is aware of Opus and things like this. You send the RTP packets that way, and that component should be able to figure out what to do with the media packets. So it's really as simple as that. And another interesting aspect of this is that we do support multicast in this case, which means that if you have a multicast-aware network, then you can RTP forward the packets to a multicast group instead, and then all the components subscribed to that multicast group can receive the same RTP stream at the same time, which means that there are interesting things that you can do there. And an interesting part is that we also added some basic RTCP support to help in some scenarios, and I'll address these a bit later in this presentation when I'll talk a bit more about scalability aspects. But in general, there are several things that you can do with these RTP forwarders, and don't let the name fool you. RTP forwarders are just basically packet forwarders rather than RTP per se, because we use the exact same feature for data channels as well. And I'll show a quick demo of that too in a minute. And basically what we do anytime we receive a data channel message, we can just forward these as a plain UDP message somewhere as well, so that you can also use these text messages or binary messages for something else as well. And if we go back to the diagrams that I was showing before about the couple of proactive plugins that we have, if we take into account the Audio Bridge as an audio MCU, it means that we have WebRTC participants talking to each other, creating a mixed conversation somehow. And then what RTP forwarders can do in this case is basically forward the mix to another component. And so, for instance, a very simple example, you are having a conversation between three people, as we see here. You have a mix that contains the mixed contents of this conversation. You send it via plain RTP to, I don't know, FFmpeg, and then within FFmpeg, you can do some more processing of it, or you can record it, or you can convert it to something else, or you can turn it into a podcast broadcast via HLS, whatever you want to do with it. Once it's available as a plain RTP stream, it means that you have a lot more tools that can actually play with it any way that you really want. And the RTP forwarding syntax is actually quite trivial, because what you need to do when you create an RTP forwarder is just basically, in the context of the Audio Bridge, you just need to say which room you want to forward, and then most of these options here are optional. What is really relevant is the host address that you want to send the stream to, and the port that you want to send this to, because we are creating a monodirectional UDP stream, let's say. So it's really as simple as that. And it's quite similar for the Video Room as well, with the difference, of course, that since the Video Room does not mix anything, what you can forward are the individual participants instead, which gives you also a good deal of flexibility and freedom in this context, because it means that if I am assuming that, for instance, this publisher here is sending his stream, and we are forwarding it to these two other WebRTC participants in the room, at the same time, using RTP forwarders, we can also relay this audio and video stream via plain RTP to another component for further processing. And in this case, it can be, again, FFmpeg or GStreamer or even Janus itself, as we'll see later, for really a lot of different use cases. And I'll show a couple of demos in a minute. And again, the syntax here is quite simple as well and very similar to the one before, with the difference that since the video room is an SFU and video is involved too, you may have to provide a couple of ports rather than a single one. You may want to address an RTSP port as well. And most importantly, there is also, it's not displayed here, but you also have the ability to forward more than one stream if you're actually doing simulcast. So by simulcast, I mean that you are sending 3 different streams at the same time of different quality for a better user experience for the viewer's side. If you want to have access to all of these 3 streams for one reason or another, you can actually do that via plain RTP streams. And let me just show you a demo real quickly. And first of all, for instance, one of the things that we could do with this is just basic image processing. So OpenCV comes to mind because it's a common tool. And so in this case, for instance, you could have a user sending their WebRTC stream to Janus somehow, Janus sending it via plain RTP to a component. And this component may be OpenCV that could be used, for instance, to analyze the video stream for anomalies or for identity verification or for a lot of different things. I'm not going to show you a demo using OpenCV, but I can show you a couple of simpler demos using just plain GStreamer, for instance. And to do that, we'll use the video room plugin to actually send a video stream. And we'll use basically GStreamer to show you how you can receive an RTP forwarder to do a few things. And let's just show you a very simple example where we just display the video that we are receiving. And to do that, we can use this very simple script that is called forward recipients video only. In this case, we are interested in just receiving the video from a WebRTC participant and displaying it locally. And this GStreamer pipeline does exactly that. So it's basically tailored to receive media on this port over here, 17004, expecting DP8 and then displaying the content, which means that we can start this forwarder. Let's join the room first, just so that I can start sending my media, which is over there. I can start this script to start waiting for packets. And if I want to actually send media to this port right now, I can create an RTP forwarder, which I can do, in this case, again, via JavaScript for simplicity, but we could also do it more programmatically in other ways. I'm basically just saying to RTP forward my ID to my publisher, the one that you see over here, from this room to this address, which is the one that we just saw. So let's just do that. And magically, as you can see, GStreamer is receiving the packets and is able to basically display media, even though it was not actually connected to the WebRTC room at all. So it didn't do anything of that sort. And as I was saying, I mean, this is already a very simple and quick example, but as I said, it's also interesting to show how you can do that with simulcast instead. So let's publish with simulcast in this room instead. In this case, I'm publishing again, but I'm actually publishing 3 different versions of myself. So I'm actually sending a high, a medium, and low quality of myself. And so I actually have a script to receive, if I want, 2 different versions at the same time, which is this GStreamer script over here, which binds to the 3 different ports and then displays them separately from each other. So let's launch this script as well. And then let's send a new forwarding request to Janus to actually say that we want to send more than one stream at the same time instead. So as you see, it's very similar to the one that we saw before, but we're not just sending one to one port. We're also saying that we want to send the other 2 layers of the simulcast stream. So let's send this. And here you should see, I think, 3 different streams over here. And you can see that it's exactly the 3 streams that I was mentioning before. So my browser is sending 3 different qualities of the same stream. It's sending a high quality stream in case the viewer has enough bandwidth, a middle quality stream in case he has some trouble receiving things, and a thumbnail that can be used for different things, for users with problematic network, or because maybe you just need a thumbnail in this specific context of the application. So again, very simple and quite effective. And of course, there may be other things that we may want to do with the media. So we may want, I was mentioning in this glitch processing, in this case, I'm just displaying stuff. So let's show some other things that we can do with media instead. So let's, for instance, just for the, as an example, I have another script over here that is still based on GStreamer and is similar to the other ones, but instead of displaying anything, this GStreamer pipeline just decodes the media, the video, and then saves it to a series of images every 5 seconds or so. So in this case, not really processing, but we are actually working with the media somehow to do something. So let's start this script as well. Let's join again our video room as regular participants. No need for simulcast here this time. And let's send an RTP forward message again. In this case, this tool is waiting for media on port 16004 rather than 17004. So let's do this right now. So as we see, the tool is starting to work. We don't see anything because we don't really need to see anything. Something is happening behind the curtains. So, but something is happening here. So this is actually the folder where I'm saving all of these images. And as you can see, every 5 seconds or so, something is being saved. So you can see some images of myself over here. And these are basically the snapshot that GStreamer is taking from my stream every dot seconds or so, which can be useful for several different reasons and already gives you a, let's say, a first appetizer of what you can do when it comes to actually play a bit with the media rather than just displaying it. And another interesting example is manipulating video instead, so that we can do something with this. So let's show, for instance, this other example that allows us to flip the video vertically. So basically this GStreamer script again waits for media on a specific port, in this case 1504, then decodes the media, flips it vertically so that it's flipped again, and then we re-encode it again via VP8 and send it to another port over here. And you may recognize this port because it's the one where we created the mount point before, the one for the Iron Maiden video. So which means that if everything works as expected, we'll have the video room sending media to Janus, Janus sending it to this script over here, this script transforming the video and then re-encoding it and sending it to the streaming plugin, which means that if I open the streaming plugin later, I should be able to see this flipped video. So let's try exactly this. In this case, this script is waiting for media on port 1504. So let's do exactly this. Again, we are sending a new RTP forwarder, and we can. One important thing is that you can send more RTP forward requests for the same source. So you're not just bound to one. So you are given some flexibility in this context, especially if you need to feed multiple sources at the same time. So in this case, the script is now working, and if we want to see if it is actually doing its job, we need to open the streaming plugin demo again. We have the Iron Maiden demo over here, which is not going to show Iron Maiden, but it's hopefully going to show exactly me flipped upside down. I'm probably in Australia right now. I don't know. Is it a dead joke? I'm not sure. But again, this shows that this is actually doing its job. So in this case, GStreamer is actually flipping the video, re-encoding it, and the streaming plugin is actually now displaying the outcome of this effort, which means that you can actually implement also some sort of a chained media management somehow if you want it. And again, there are several different things that you can do here. And another interesting thing is not only, let's say, manipulating the media for different things, but also possibly interacting with remote mixers and stuff like this. And this is actually something that, for instance, we do ourselves with our own custom-made MCU, which only talks plain RTP and doesn't speak WebRTC. So we actually do exactly this. So we have people join the video room, and then behind the curtains, we pass the streams to our own MCU for work. And to show you how this can work in a simple way, I'll use a GStreamer script again that will act as a very simple and dumb video mixer if you want. In this case, specifically, I have a very simple script that only waits for a single video stream on this port here, and then scales it and paints it on top of a placeholder video that GStreamer generates to show basically some video composition taking place. So basically acting as a regular NCU would work in this context. So let's start this video mixer as well. Let's join our video room once more. And let's send this new RTP forward request to the port that this video mixer is expecting. And in this case, as you can see, GStreamer in this case was configured to display the media rather than send it to somewhere else. And it's taking some time just because of synchronization issues. But in general, yeah, you can see that it's basically showing a canvas below here that is a placeholder video that the GStreamer has, and then on top of that we are painting our own video over here, which means that in general, and at least in theory, with GStreamer you can actually do a live composition of multiple participants instead to do something more meaningful than that. But again, this is just a proof of concept to show the kind of things that you can do here. A more interesting use case, if you want, is actually though when you start using this to actually broaden the availability of a WebRTC stream. And a simple example that comes to mind is something like this, which is also a very common use case. So anytime that you need to do something like WebRTC to HLS or something like this. And I actually made a demo at Camailio World a few years ago where I showed exactly this. So I showed how I would use a WebRTC stream sent by a browser to Janus. Via RTP forwarders, I would send it to FFmpeg, an FFmpeg that was on my machine. And then FFmpeg would receive and decode this RTP stream and transcode it to the RTMP stream that YouTube Live expected. Now, I'm going to show a similar demo without using YouTube itself. I'm going to use a Red 5 instance, which is basically an RTMP server that is an open source RTMP server that will be collocated on my own machine. And I'll basically show you exactly the same thing. So I'll basically have the video room over here use RTP forwarders to send something to FFmpeg. FFmpeg will send media to Red 5, and I'll use mPlayer as a player to open the RTMP stream that I created to demonstrate that it's actually doing its job. And so before we do that, let's have a look at what FFmpeg expects in this case, because it works a bit differently from GStreamer in terms of how it receives RTP streams. And in particular, it expects an SDP file to basically describe the kind of session that you want to do. And in this case, I created an SDP that binds on these two ports over here to create an Opus and VP8 stream that expects these two payload types that you see over here. And then I have a very simple FFmpeg pipeline script, here, that basically can open this SDP stream as an input and then transcode it to an H.264 stream that I'll send via RTMP to Red 5 at the same time. So Red 5 has started. Let's open my WebRTC stream again. And first of all, let's launch our FFmpeg to YouTube stream as well. And in the meanwhile, I'll copy the RTP forwarder instructions that I want to do. So I'm launching FFmpeg here. So it's waiting for traffic. This is the RTP forward request that I'll send. So as you see, I'm sending it to the ports that FFmpeg expects. And I'm also specifying the payload type that FFmpeg expects as well. So let's do exactly this. As you can see, FFmpeg has started receiving the stream, which means that now we can actually display the stream. And let's open mPlayer to show exactly this. In this case, this is the stream that I've been sending via FFmpeg. So this is the stream that I can consume via mPlayer, which means that in a few seconds I should be able to see my ugly face again in a video. And in this case, of course, the RTMP uses some buffering, so it may take a while. And of course, it's not working for some reason. Yeah, I think it took some time to actually. Let me try again, because it probably took some time before it actually figured out there was a video stream as well. Okay, it should be working now. Okay, and here you can see that this is basically the stream that FFmpeg is transcoding in real time via WebRTC. It has a few artifacts, probably because it needs a keyframe to sort it out. In fact, now it looks better. But basically, if you assume that it is not Red 5, but possibly YouTube Live or something like this, this is an easy way to have WebRTC streams be converted to something that you can then broadcast much more easily to something like like YouTube, pretty much as ClueCon is doing right now with this session that I'm sending, basically. But as I was saying, it's not only a matter of processing and transcoding and stuff like this. Sometimes RTP forwarders and stuff can also be very useful also for pure scalability or distributed access of some sort. And this is actually something that I described a bit more in detail in a presentation I made at ComCon a couple of years ago, and was actually the subject of my PhD thesis at the time. So if we assume that we have a WebRTC user here sending media via WebRTC, and we can then translate it or forward it as plain RTP, it means that we can imagine any kind of, let's say, distribution architecture over here. And if we want other WebRTC viewers to watch the stream that I was originating here, many more users that could actually consume it from a single instance, the one that I was publishing to, then all I need to make sure that WebRTC is supported at the edges, and in the middle I can do whatever I want. And so this means that I can, for instance, use WebRTC and the video room here to send the WebRTC stream, and then I can use RTP forwarding to feed multiple relay nodes that may or may not use multicast in the background, for instance. Eventually, this stream will reach multiple Janus instances over here, and using the streaming plugin, as we've seen before, for instance, with the Iron Maiden demo, I can make this RTP stream available to these Janus instances, which in turn will make it available as a WebRTC broadcast to a lot of users. So if a single instance, for instance, is able to serve, I don't know, 500 users from this stream over here, it means that if I'm able to feed 6 different instances instead rather than 1 from the same source, it means that I'll be able to serve 3,000 users instead of 500 instead. So basically, just by taking advantage of RTP forwarders to scale internally and then still using the existing plugins in Janus, I've already scaled the service much more than I could do before. And actually, this is not the only use case where RTP forwarders are helpful, because they are also helpful when you want, for instance, some sort of a geo-distributed access. Because if you have, let's say, users connected to different Janus instances in different parts of the world, by default, they would not be able to communicate, because the video room plugin only is aware of users connected to that specific plugin, so to that specific instance. But if we decouple the video room and streaming plugin, as we did with the broadcasting scenario before, it means that I can have a user here sending media via WebRTC to the video room plugin over here. Then I use RTP forwarders to send the media stream to other Janus instances, and these Janus instances can have a streaming plugin mount point ready to actually make these users stream available via WebRTC to these other participants as well. And again, you know that these are different plugins because you are actually orchestrating the logic and so on, but the users themselves do not necessarily need to know that. They only see WebRTC streams going back and forth. So if you orchestrate this correctly and so on, this makes for a very easy way to actually distribute media much more effectively. And let me show you exactly how we can do this using the video room and streaming plugin specifically in a couple of ways, mostly because I want to show an important feature that we added exactly to address that part. So if we want, for instance, to have a user, a web video room user, let's say I'm connecting here to Janus and I'm a WebRTC participant connected to this instance of Janus, and let's assume that this streaming plugin instance is actually connected to a completely is actually part of a completely different Janus instance. It means that I can create a new streaming mount point for this participant. Let's say I'm creating one that I'm calling remote publisher, binding to these 2 ports over here. Now the streaming plugin has a new mount point called remote publisher that we can subscribe to. In this case, we are not receiving anything yet because nothing is feeding this component. So let's actually use RTP forwarders again to do exactly that. We will send our media streams, and immediately you see my face over here. Let me mute again. And again, as you see, this was very simple and a very simple and effective way of doing things. But one thing that is not immediately apparent, because I actually created the mount point before actually doing the RTP forwarding, is that if you just do this out of the box, you may encounter issues. So let me just show you this in practice. So now we are forwarding, the streaming plugin exists and so on. Let's assume I am a new viewer. I connect again. Now media is actually coming in, but I'm not seeing anything. It took a few seconds for a simple reason, that actually I wasn't the stream. As a user, I wasn't receiving a keyframe right away, which can be a problem, especially if the source, this video room publisher that you see over here, does not send keyframes on a regular basis. In this case, I was actually sending one every 10 seconds or so, and so it took only a few seconds to work again, but this is not something that can be relied upon. So a better way to actually take care of this is to actually take advantage of RTCP support for the purpose. So we have a way to create a backend RTCP channel between publishers and between the streaming plugin and the video room. And let me show you how that works using the streaming plugin again. So let's create a different streaming mount point, one with RTSP, which bounds to a different port instead. And let's now create an RTP forwarder for this stream before we actually subscribe to the stream, so that we should actually be in the same case that I was mentioning before. So now I've created the RTP forwarder. Let me subscribe to the stream again. Now I received something immediately. So and that's basically because the streaming plugin received the keyframe request from this browser that was actually asking for the stream, and forwarded these keyframe requests behind the curtains to the remote Janus instance. In this case, they are co-located, but it's actually the same thing. This Janus instance knew that it was related to this publisher, so sent the keyframe request back to this browser, and this browser generated a new keyframe just for this participant, which means that if I just do it again, I can do it as many times as I want. I'll always receive a stream right away. So that's basically very useful anytime that we actually need to do these sort of things. And an interesting thing is that the same thing that I was mentioning before for simulcast also applies for this kind of broadcasting as well, because one thing that we can see, for instance, is that if I subscribe to myself using simulcast, let me show you quickly using this demo over here. you can see that some additional controls basically allow me to choose which substream I want to receive. So in this case, I was receiving a high quality stream. Now I'm dropping to the medium quality. Now I'm dropping to the low quality, and you can see the bitrate changing. Now I want the high quality again, and so on and so forth. This is one of the things that Simulcast gives that is really effective. But if we want to make this available to remote subscribers as well, what we can do is again take advantage of RTP forwarders, because we've seen it working. But most importantly, the streaming plugin supports Simulcast as well, which means that if we go over this demo here and create a new streaming plugin instance that creates a Simulcast approach instead, so we are binding to multiple ports and we are creating a Simulcast stream, it means that now we have a Simulcast publisher that we can subscribe to. So let's feed it with the RTP forwarder again. This time we want to send all of the streams at the same time. Now the streaming plugin is actually receiving these multiple streams. So let's subscribe to that. And as you can see, we see exactly the same thing that we were seeing in the other demo. So even though these two plugins are actually not really co-located and not really aware of each other, we are still able to access the Simulcast stream, and so are able to basically switch among the different streams that we want, exactly as if we were subscribing to a local participant instead. So this means that it makes for a very powerful mechanism over here. And I'm getting short on time, so I'll just go quickly to the last slide. So just to explain that this is exactly what we are using in our own virtual events platform. So for instance, we are going to provide once more remote participation support at the ITF meetings, and all of the things that I've showed you before are actually what we are using in our own platform. So in this case, for instance, we are using the audio bridge as a way to mix the audio streams of the active participants, and then we make this mix available as a broadcast of participants, so that if we have 300 viewers, they don't need to join the audio mixer to actually receive media, because they would weigh on the CPU. We only mix the active participants, and they receive the already mixed stream as a broadcast via the streaming plugin instead. And we do the same for video. So video streams are sent on any Janus instance, and then these streams are made available on all of the broadcasting instances instead, which means that as a participant of these virtual event platforms, no matter which Janus instance you end up connected to, you still see exactly what everybody else is seeing. So this makes for a very effective approach. And as I mentioned, since we support multicast as well, this means that this virtual event platform could take advantage of this as well if the underlying network provides support for it to do something like this, basically. But it's not something that we've done, because most of the cloud providers that we use for the purpose don't support multicast. But it's nice to know that we actually have these available. And this actually covers everything. So I don't know if we have time for some very brief questions, or if I actually ran out of time, but I hope that this proved informative and actually will encourage you to start tinkering a bit with Janus to do some creative things. Thanks for your attention.
A man of your community contribution and intellectual powers can always have a minute or two for questions. And
that's great. Thanks.
There are a couple in the chat, so if I can direct you to the chat for a moment, you'll notice there's one called Rants and one from Afshin.
Okay.
So
yeah. Okay.
Please.
Yeah. Rance is asking, curious if the streaming plugin supports using multicast IP as well. It seems like it should, as it is more concerned with the prototype. The streaming plugin, both the video room, so both the RTP forwarders and the streaming plugin do support multicast IP addresses, and we've actually used this in some context, which means that you can have a video room publisher send, using RTP forwarders, a stream to a multicast IP group, and you have multiple Janus instances and streaming plugin instances all subscribed to that same multicast group, and they all will receive the same media from that same user. So multicast can indeed be used in this context. And then a question from Afshin: can an FFmpeg run on user's machine to offload transcoding from Janus server? I mean, you can use these examples that I used to, for instance, generate an RTP stream to then send a plain RTP stream to a remote Janus instance. The only issue here is that a plain RTP stream doesn't have any feedback or reliability mechanism as WebRTC has. So in this case, for instance, the stream that you may be generating via FFmpeg and sending to Janus on AWS, for instance, it may end up there, but you may end up with some lost packets on the way, and these lost packets will not be recovered. So it's usually easier and better to take advantage of WebRTC for anything that the users send up to the edge nodes instead, and then work with tools that just work with plain RTP in a network where you have much more control, and when you know that there is not going to be any loss involved. And by the way, all these examples were co-located, but it doesn't really mean that GStream or FFmpeg need to be co-located with Janus. So you may have Janus on an edge server on AWS and have a different AWS machine where you have FFmpeg and GStreamer doing the transcoding. Since they may be part of the same security group and same virtual network, they would be able to interact as if they were on the same LAN, basically. And so you still have the same end results without stealing resources from Janus, because you're actually using a different server. So you can definitely do a lot of things here.
Great. Thank you very much, Lorenzo. What we'll do is we'll call an end to the formal session now, and then that will allow people to stick around in the room to ask you further questions if there are any. I didn't realize, but just looking at the schedule, it's an Italian takeover this afternoon. You've kicked it off, and then the other Lorenzo, or another Lorenzo in VoIP, Lorenzo Mangani, is going to be over in the Homer workshop room. That's in about 25 minutes time. And then after that, we've got Luca Pradavera doing a workshop as well. So 3 Italian-driven workshops this afternoon. We're very grateful.
Yeah, and basically we have 2 Lorenzos here today, the clever one, and then there's me. So
we have excellent Lorenzos in there. If only we could have that third Lorenzo. We'll get him.
Yeah, exactly. Maybe next time. Oh, I see there's another question. Sorry about that. So can one use Janus in reverse, not as WebRTC server, but as WebRTC client connecting to some WebRTC serving to some web server serving WebRTC content and translate it in plain zip, for example? So it could be done. So you can basically orchestrate. So you still need to do some orchestration yourself. So Janus will not act as a client itself. So it's up to you to create the connections, because Janus only acts as a signaling server in this case. But if you do some orchestration and make sure that you take the offer from the other WebRTC server and pass it to Janus, and you take the answer from Janus and send it back to this other server, then you can actually do these things. And actually there was David mentioned Luca Pradavera actually made exactly this example using Janus and FreeSwitch to actually talk to each other. So he basically created some WebRTC connections between these 2 components that could actually do exactly this. And Stephen Dame asks if Millicast uses Janus under hood. No, it doesn't use Millicast, it doesn't use Janus, but we know the Millicast people very well, because it's basically Cosmos Software is it's a company which we are very good friends with, and so we are basically using the same kind of approach in terms of distributing media streams and so on. They are using a different media server that is called Meduse, but we exchange ideas all the time, so we're actually good friends with them.
Okay, thank you very much for that, Lorenzo. We will call the session to a halt now. It's been great having you along. Thank you for going into those details that you did, and that very practical demonstration as well. So thanks again. A big ClueCon thank you to you, Lorenzo. Thank you very much.
Thank you. Thank you for the opportunity, and have a nice day.
You're very, very welcome. I would just like to say hello to community friend Alexander Dubov-Ikov, who's shown up. He was next to Lorenzo Mangani, but he's disappeared off for a minute. And so let me just remind everybody that the Homer session is in the Homer workshop room at 2:30 Central Time. That's 21 minutes from now. But if you'd like to stick around and ask Lorenzo any more questions, I'm sure he'll be here for a while. So thank you very much, Lorenzo, and bye-bye for now.